Welcome to section 11.2. In this section we're going to learn about the quadratic formula, and you will love this formula. It makes it so much easier to solve quadratic equations. So first let's look at where it comes from. Okay, the quadratic formula is the formula that gives the solutions, or x, to the quadratic equation ax squared plus bx plus c. So what we're going to do is we're going to take this general equation right here and we're going to complete the square on it. And that's a derivation of the quadratic formula so that you can see where it comes from. So when we work with things like this, the first thing we do is divide both whole sides by the coefficient of x squared, which in this case is a. So I'm going to divide both entire sides of this equation by a. Now keep in mind a, b, and c are just coefficients. They're just numbers. X is the variable that we're solving for. Okay, when I do that, I'm going to split this into three fractions on the left side. And on the right side, 0 divided by a is 0. Those a's cancel, so we have x squared plus b over a is really the coefficient of x there, plus c over a equals 0. But you know what, actually I'm going to go ahead and do the next step of completing the square, which is to move the constant term, that is the term without any x's, over to the other side. And now let's do what we did before and go off to the side and figure out what we need to add to both sides. So you take that coefficient of x, which is b over a in this case, you divide it by 2. Okay, that's the equivalent of multiplying by half when we multiply by the reciprocal, so we get b over 2a. And then you square that. If you square b over 2a, you get b squared over the denominator squared. 2 squared is 4, and a squared is a squared. So what we're going to add to both sides is this right here, b squared over 4a squared. So I'm going to add that in right here and right here. And now we can rewrite the left side as a perfect square. Remember, it's x plus this number, which is what you get when you divide the coefficient by 2. So plus b over 2a all squared. And on the right side, in order to simplify that, I'm going to need a common denominator. So one denominator over here is a, and the other denominator is 4a squared. So they both have an a already, so all I need is in the first fraction I need another a and a 4. So we'll multiply this first fraction by 4a over itself. And then the second fraction, we'll leave it as is. Okay, now I'm ready to take the square root of both sides. And actually though, before we do that, let's go ahead and clean up this right-hand side just a little bit more. Okay, so this multiplies, this numerator here, to negative 4ac, if we put the variables in order. And then this fraction has a numerator of b squared, so when we add them, we have this over 4a squared. And my left side is still the same. Okay, now let's take the square root of both sides. So on the left, the square root and square cancel to give me x plus b over 2a. And on the right side, because I have a variable squared under radical over on the left, I need a plus or minus, giant square root of all of this stuff. Now because of the way it's written in a standard form, you usually put the b squared first. So I'm going to reverse the order of the two terms here in this numerator and write it as b squared minus 4ac all over 4a squared. And now we just need to solve for x. So we're almost there. All we have to do is subtract b over 2a from both sides and then keep simplifying as well. So subtracting that, we have negative b over 2a plus or minus this whole radical. Now I'm going to split this into the radical of the numerator over the radical of the denominator. And I'm doing that because the radical of the denominator will actually simplify. So the square root of 4 is 2, and the square root of a squared is a. So we get square root of b squared minus 4ac over 2a. And now notice we have the same denominator here and here. So we can write it as a single fraction, and this is how you will normally see the quadratic formula all written, is negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula right there. That is a shortcut formula that will give you the solutions to a quadratic equation of this form. Now it does have to be of this form, meaning it has to be set equal to 0 on one side. Okay, that's the quadratic formula. Yay! You will need to memorize that. Okay, so let's use it to solve this equation right here. 2x squared plus 9x plus 10 equals 0. Okay, so we're going to jump straight to it using this quadratic formula. So we have x equals, and now what I recommend you do is you write the quadratic formula every time, and before you know it, you'll have it memorized. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we have to do is identify what is a, b, and c. Well, those are these coefficients, and you do include the sign. So a is positive 2, b is positive 9, and c is positive 10. So plugging all of those in, we have negative b would be negative 9 plus or minus the square root of b squared would be 9 squared minus 4ac is minus 4 times 2 times positive 10 all over 2a, and a is 2. So that's what we have when we just plug it straight in. I haven't simplified anything. And then from here, that's what you do, is you just simplify. So we have negative 9 plus or minus the square root of, let's figure out what this simplifies to. 9 squared is 81. 4 times 2 times 10, that's going to be 80. And this is all over 4. Well, 81 minus 80 is 1, so you have negative 9 plus or minus the square root of 1 over 4. We're getting close, but we can keep simplifying because the square root of 1 is 1. So we have negative 9 plus or minus 1 over 4. So now there's two answers here, so let's write them out separately so that we can simplify each of those. One goes with the positive, one goes with the minus. So these two solutions are negative 9 plus 1, that would be negative 8, and negative 8 divided by 4 is negative 2. And over here we have negative 9 minus 1, that's negative 10. Negative 10 fourths is equivalent to negative 5 halves. So those are the two solutions to this quadratic equation that we got using the quadratic formula up here. Okay, now you should get the same answers regardless of the method that you use to solve a quadratic equation. So you have three methods now. You've got the quadratic formula, factoring if it works, and completing the square. So just for this example right here, let's do the other two ways as well so that you can check and see how that you do get the same thing. It's also just to review you on those other techniques. Okay, so this one will factor. I chose this one specifically so that it will factor. Now one of the terms is going to have a 2 in front of the x to give us that 2x squared. The other one will just need a coefficient of 1. Both are positive, so we're going to have a plus and a plus. We want them to multiply to 10 and add to 9, the outside and inside terms. So there's a little bit of guessing and checking going on here. I would probably try 5 and 2 first. Let's see, if we put a 5 here and a 2 here, then our outside terms would be 10x and our inside terms would be 2x, which add to 12x. not 9x, so that doesn't work. Let's try switching them. If we put the 5 there and the 2 there, then our outside terms give us 4x, and inside terms are 5x, which do add to 9x, so that does work. So we have that equals 0. Then you set each factor equal to 0 and solve each of these equations. So we get x equals negative 5/2. There it is. And x equals negative 2. There it is. Okay, now you're probably thinking, wow, factoring was a lot easier. And you're exactly right if you're thinking that. Factoring is a lot easier if an equation factors. Now, if an equation does not factor, then you can't use this method, and the quadratic formula really typically is the fastest and easiest method. Okay, the method that is least often used, though, is the completing the square method. So let's do it with this one as well. Partially for review, you still need to be able to complete the square. The skill of completing the square is actually used in college algebra, not for solving quadratic equations, but for rewriting quadratic functions in a different form. So you'll need the skill, even though you're not going to be necessarily using it every day, to solve quadratic equations, at least not after you pass this class. So there is a reason why you're learning this skill. It's because it's needed in college algebra. Okay, so for completing the square, we start by moving the 10 over and getting it out of the way. So we have 2x squared plus 9x equals negative 10. We also need to divide both sides by that leading coefficient of 2. So I'm going to do that at this step. That's going to, when we break this up into two fractions, we'll have 2x squared over 2 plus 9x over 2 equals, that is negative 5. So we have x squared plus 9/2 x equals negative 5. Then to figure out what to add to both sides, we take this number, divide it by 2 and square it. 9/2 divided by 2, that's equal to 9/2 times 1/2, or 9/4. Then if we square 9/4, we get 36 over 16. So that's what we're going to add to both sides. So we have x squared plus 9/2 x plus 36 over 16. And actually, why don't we simplify that first? 36 and 16 are both divisible by 4 at least. 36 divided by 4 is 9. 16 divided by 4 is 4. And that is completely wrong. 9 squared is not 36. 9 squared is 81. Don't know what I was thinking there. Should have had 81 over 16. So we add 81 over 16 to both sides. And now we can rewrite the left side as a perfect square as x plus this value, 9/4. It's a 9/4, all squared. And the right side we need a common denominator, so I'm going to multiply the negative 5 by 16 over 16. And negative 5 times 16 is negative 80. So I'm rewriting that as negative 80 over 16, that's equivalent to 5, plus 81 over 16. So we have x plus 9/4 all squared equals negative 80 plus 81, that's 1, so 1/16. Out of space, let's come over here. Now we can take the square root of both sides. And on the left we have x plus 9/4. And on the right we have a plus or minus, don't forget that. Square root of 1/16 is 1/4. So we get x equals negative 9/4 plus or minus 1/4. Now it doesn't look the same as the other answers we got, but let's split up the positive and the negative answer and keep going here. So the positive answer is negative 9/4 plus 1/4. Negative 9 plus 1 is negative 8. Negative 8/4 is negative 2. And the negative answer would be negative 9/4 minus 1/4. That's negative 10/4, which is negative 5/2. So as you can see, we still get the same answer no matter how we solve it. And those are all three methods you have for solving a quadratic equation right there. Okay. Okay, the main focus here though is on this new quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you memorize that. You'll be expected to have that memorized when you walk in the door on the first day of college algebra. That is something you should know. Alright, so let's practice using it some more. Let's solve the rest of these all using the quadratic formula. Before you use the quadratic formula, you do still have to do just like with factoring, get one side equal to 0. So first let's move that 2 over to get 3x squared minus 8x minus 2 equals 0. Then we can use the quadratic formula, which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you put your x equals. For some reason, a lot of students leave that off, but then it's unclear what you're solving for. So you're solving for x here. Negative b is the negative of negative 8. Okay, let's write out what a, b, and c here are. A is 3. B is actually negative 8 because you do include the sign. And c is negative 2. So write those out if you need to. Okay, when we plug all of those in up here, we get negative b, so we have the negative of negative 8 plus or minus the square root of b squared. Now this is wrong. That is wrong to write negative 8 squared because you have to square the negative as well as the 8. So you have to have parentheses around that negative 8 before you square it. Be careful about that. Minus 4a is 3 times c is negative 2. All over 2a, so all over 2 times 3. Basically, you just have to be real careful about your arithmetic and your negatives, and you'll be fine here. So that negative 8 is positive 8 plus or minus the square root of negative 8 all squared is 64. Then we have a negative times a negative, so it's going to be a positive. 4 times 3 times 2. Well, that's 12 times 2, so 24. That's over 6. 64 plus 24 is 88. So we end up with 8 plus or minus the square root of 88 over 6. Now we're not done. Let's see. 88 square root of 88 probably simplifies. I know it's divisible by 2 and I get 44, which is also divisible by 2 and I get 22. That's divisible by 2 to get 11. So I can at least pull a pair of 2's out. So that becomes 8 plus or minus 2 radical 22 all over 6. Now, all three terms here, this 8, 2 radical 22, and 6 have a common factor. Now you cannot just do this. This is wrong. 8 over 6 simplifies to 4 over 3. You can't cancel things or simplify things like that until everything is factored. And this numerator is not factored because it has a plus or minus. So make sure you factor before you cancel. So we can pull a 2 out of the numerator and we're left with 4 plus or minus radical 22 all over 6. Now everything is factored. So now you can simplify the 2/6 and say that's equivalent to 1/3. So your fully simplified answer then is x equals 4 plus or minus the square root of 22 all over 3. Those are the two exact solutions. Okay, make sure you're trying these without me first. Next, let's solve this one, which has fractions involved. You really just have to be extra careful with your arithmetic, but the work is the same. So let's start by writing the quadratic formula up here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's also identify a, b, and c. A is the coefficient of x squared, which is 1/8. B is the coefficient of x, which is negative 1/4. And c is the last term, which is negative 2. Now you actually have two choices here. You can solve it like this and use these fractions. And as you can see, it's going to get a little messy, when you start squaring fractions and subtracting them under radicals, it's just going to get messy, okay? So you can do it that way. What I recommend doing is actually getting rid of all the fractions first and then solving. And it's not that hard to do because you can do anything to an equation as long as you do it to both sides, and it's completely legal. So ask yourself first, what would we need to multiply both sides of this equation by to eliminate both of these fractions? These two denominators are 8 and 4. So the lowest common multiple of 8 and 4 is 8. So it looks like if we multiply both entire sides of this equation by 8, that should eliminate the fractions. And if you don't like working with fractions, just do this. So I'm multiplying both sides by 8. Then when I distribute that out on the left, we'll have 8 times 1/8 x squared. So that's just x squared. Minus 8 times 1/4 x. 8 over 4 is 2, so that's 2x. And 8 times -2 is -16. Then on the right side, 0 times 8 is 0. Now there is nothing wrong with just solving this equation instead. It'll have the exact same solutions. So instead, I'm going to solve this one because it looks easier. Okay, so if we do it this way, we have to re-identify what is A, what is B, and what is C. A is the leading coefficient, which in this case would be 1. B is this coefficient, -2, and C would be the -16. Now the numbers are going to be bigger, but at least they're not fractions. Okay, so we have negative B. Negative B would be the negative of -2, so +2, plus or minus the square root of B squared. Remember that's -2 all squared. Keep those parentheses there. Minus 4 times A times C. All over 2A. And I think it's best if you write them all out until you get really good at this. Just like I did right here. Write everything out. And be very careful. Don't try to simplify too much in one step or you'll really risk making a mistake. Okay, B squared is 4. -2 squared is 4. Then we have a minus times a minus, so it'll be plus 4 times 16. That's 64 all over 2. So let's come up here. We have x equals 2 plus or minus the square root of 68 all over 2. 68 is divisible by 2 to give us 34. That's divisible by 2 to give us 17. So we can pull a 2 out. So that's 2 plus or minus 2 radical 17 all over 2. Now in simplifying, remember, you cannot do that. Those don't cancel until everything's factored. So first factor out a 2 of the numerator, and you're left with 1 plus or minus radical 17 all over 2. Now it's factored. Now we can cancel the 2's. So we simply get 1 plus or minus radical 17. Alright, let's do another one for practice. Solve x equals -2x squared minus 2. Okay, try this on your own first. Now the mistake that most students will make on this is they'll forget to set it equal to 0. But it's a quadratic equation, so you have to set it equal to 0 first. So first, let's move this x over to the other side to get -2x squared minus x minus 2. Now that's a lot of negatives. Every single term is negative. So let's make life easier on ourselves and let's multiply both sides by -1. That's completely legal. Then on the left we have 0, and on the right, if we distribute that -1 out, it just makes all our terms positive. So that's a little easier to work with. And then now we can use the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to write out a, b, and c this time because it's pretty clear to read it off of this equation. B is the coefficient of x, which is 1 right here. So negative b is negative 1 plus or minus the square root of b squared is 1 squared minus 4 times a times c all over 2a. So now let's simplify under that radical. 1 squared is 1 minus 4 times 2 is 8 times 2 is 16. So under the radical we have square root of negative 15, which means this does not have any real solutions, but we can still find its imaginary solutions because we're taking the square root of a negative number here. So let's keep going with it. So this is that radical 15 is not simplified because 15 breaks down into 3 and 5, but we can pull the negative out and make it an I. So we can write this as negative 1 plus or minus I times radical 15 all over 4. And really that's as simple as it gets. Those are the two imaginary solutions to this equation. Alright, now how do you know if an equation is going to have real solutions, one real solution, two real solutions, or no real solutions, such as in this example? There's a shortcut way to figure that out, and that's by looking at what's called the discriminant. The discriminant is the radicand, that's what's under the radical, in the quadratic formula. So this right here, b squared minus 4ac, that is the discriminant, b squared minus 4ac. Now you can use that to tell how many real solutions you're going to have, because if that's negative, as in this case, you'll have no real solutions. It doesn't even matter what everything else is. It doesn't matter what this negative b is out here, and it doesn't matter what the 2a in the denominator is. If what's under the radical is negative, you're going to have no real solutions. So that is one of the things here. If b squared minus 4ac, if it's negative, then you're going to have 0 real solutions, but you will have 2 imaginary solutions. Or rather, I should say complex solutions is more technically correct. Now, if b squared minus 4ac, what's under the radical, is positive, let's go look at some of our previous examples for that, such as just this right here. Here's b squared minus 4ac, in this example, was 68. Now, if that's a positive number, you're going to end up with 2 solutions because you have a plus or a minus in front of that. So you'll always have 2 solutions if that radicand is positive. You have 2 real solutions then. And the last case is what happens if that b squared minus 4ac is equal to 0. And we don't have an example on this page, but if that's equal to 0, we can look at what would happen. Let's just take this off to the side here and imagine for a second that this said 2 plus or minus the square root of 0 over 2, in which case the radicand is 0. Well, if you add or subtract 0, you're not doing anything to it, so you can just not even write that whole part right there because that doesn't have any effect on it. So you just get 2 over 2 or 1. So if the radicand is 0, b squared minus 4ac, then you're just going to have one real solution to your quadratic equation. That's kind of rare, but you will see that on occasion. Alright, so let's use the discriminant to determine the number and the type of solutions to each of these 3 equations right here. So our first one is x squared plus 4x plus 4. So all I want to do is see if it has real or imaginary solutions and how many. So let's compute b squared minus 4ac. B squared is 4 squared minus 4 times a is the coefficient of x squared, is 1. C is the constant term, which is positive 4. So we get 16 minus 16, or 0. So because the discriminant is 0, that means we will have one real solution. In this next example, we have 5x squared plus 7. Now there is no b term. right? So you could think of this as 5x squared plus 0 times x plus 7 equals 0. Now it's obvious that b is the coefficient of x, which is 0 in this case. So if we compute b squared minus 4ac, we'll have 0 squared minus 4 times a, which is 5, times c, which is 7. So whatever that number is, it's negative, right? That's 35 times 4, which is 140, negative 140. It's negative is the point. So when you solve this quadratic equation, you're going to get this case, 0 real solutions, but there will be 2 complex solutions. And let's look at one last example, and that is 3x squared minus 2x minus 2 equals 0. So let's compute the discriminant. B squared minus 4ac is, okay, b squared is negative 2 all squared, make sure you've got those parentheses there, minus 4a is 3, c is negative 2, that negative is included, so we get 4. Negative times a negative is going to make that a positive. 4 times 3 is 12, times 2 is 24, so we get a positive 28. So if that's the discriminant, then that means this equation has a positive discriminant, so we're in this case right here. It'll have 2 real solutions. So you don't have to do the whole quadratic formula to figure out how many real solutions or complex solutions there are. All you have to look at is the discriminant. Okay, now remember, this is just kind of a review real quick. X-intercepts, those are where a function equals 0, or in other words, where the function crosses the x-axis. The solutions to this equation are the same as the x-intercepts for this function, because when you solve for the x-intercepts of f of x equals ax squared plus bx plus c, you would set f of x equal to 0, like it says right here, and you would solve. So this is kind of interesting, and this is something that you'll explore a lot of in college algebra, and that is intercepts and graphs of quadratic functions. If the discriminant is greater than 0, so that means the discriminant is positive, then you're going to have, based on up here, you're going to have 2 real solutions. Those 2 real solutions then correspond to these 2 x-intercepts of this function. F of x equals ax squared plus bx plus c. If your discriminant is equal to 0, that's when you only had 1 solution to the equation, which corresponds to 1 x-intercept. Or if b squared minus 4ac is less than 0, that's if it's negative, that means there's no real solutions, which mean there are no x-intercepts. So your graph might look something like that. Okay, that's just a quick aside for you. Let's look at some applied problems. All right, so that's it for the quadratic formula, but let's do a couple more applied problems. Given this diagram over here to the right, this is a sidewalk here, approximate to the nearest foot how many feet of walking distance a person saves by cutting across the lawn instead of walking on the sidewalk. Now you might say, what? But what we want to do is see how many feet of walking distance they save, okay? So let's figure out, if we know that this distance is 15 from there to there, and we know that this distance right here is 3 longer than this distance, okay? The picture's obviously not drawn to scale, but that's okay. So if we call this distance x, we can call this distance 3 more than x. We need to figure out these 2 distances, the distances of the sidewalks, so that we can compare it to this distance across the diagonal, which is 15. So what could we do to set up an equation that would allow us to solve for x? So you have to think about, what all have I learned in my life, particularly about right triangles, because this is a bird's eye view, that's a right triangle. And what do I know about the 3 sides of a right triangle? And hopefully what comes to mind is the Pythagorean theorem. which remember we've looked at before. If you have a right triangle whose sides are A, B, and C, that's C there, the Pythagorean theorem says that A squared plus B squared is equal to C squared. In other words, the length of one leg squared plus the length of another leg squared is equal to the length of the hypotenuse squared. So we can apply that to this triangle to get x squared plus, that's the one leg squared, plus the other leg squared is x plus 3 all squared equals the hypotenuse squared, 15 squared. So now we have an equation which we need to solve. And if you look at it, you might recognize this as being a quadratic equation. We will have to FOIL this out to simplify it because we have to get, if we were going to use the square root property, we'd have to get all the x's together as x plus 3 all squared. But there's also this other x squared over here. So first thing we have to do is combine all the like terms. So we're going to do that by FOILing this x plus 3 all squared all out. And at the same time, let's simplify the right side. 15 squared is equal to 225. So over here we have x squared plus 3x plus 3x plus 6x plus 9 equals 225. And if you couldn't tell before, now you can definitely tell this is a quadratic equation. So x squared plus x squared is equal to 2x squared. And quadratic equations, when you solve them, remember you have to get them equal to 0 on one side. So I'm going to subtract 225 from both sides to get negative 216 right there. Now one thing you can do in this example to make the numbers a little smaller is you could divide both sides by 2 because 2, 6, and 216 are all divisible by 2. So that's what I'm going to do. Actually, I'm going to factor out the 2 first. 216 divided by 2 would be 108. And then if you divide both whole sides by 2 at this point, those on the left cancel. And on the right, we'll just have 0 over 2, which is 0. So far, we have x squared plus 3x minus 108 equals 0. Now, this is one that maybe or maybe doesn't factor. I don't know. But 108 is a big number to play with and kind of hard to factor. So I'm just going to go straight to the quadratic formula. And that's what I really would do if I was solving this, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just write it all in here. Negative b will be negative 3 plus or minus the square root of b squared is 3 squared, which is 9, minus 4 times a, that's the coefficient there, is 1, times c, negative 108, all over 2a. Simplifying under this radical, we have 9 plus, because we have a negative times a negative, 108 times 4 is equal to 432, and this is all over 2. So keeping on simplifying, 9 plus 432 is 441. And if you just try to take the square root of 441, it does in fact work. 441 is a perfect square because we get plus or minus 21 over 2, which means one of our answers is 3 plus 21 over 2. Oh, negative 3. Negative 3 plus 21 over 2. That would be 21 minus 3 is 18. 18 over 2 is 9. And the other answer is negative 3 minus 21 over 2. Negative 3 minus 21 is negative 24 over 2 is negative 12. So those are the two solutions. Now ask yourself, this is an applied problem, so does negative 12 make sense? And the answer is, of course, no. X cannot be negative 12 because you can't have a negative distance. So we'll just ignore that one. It's called an extraneous solution. And so our real answer is x equals 9. Okay, but that's actually not the answer to the question, so I'm not going to box that. Instead, it says approximate to the nearest foot how many feet of walking distance a person saves by cutting across the lawn instead of walking on the sidewalk. So we need to figure out how far a person would walk on the sidewalk on this problem. So let's see, if x is 9, then the walking distance on the sidewalk would be that distance, which is 9, plus this distance, which would be 9 plus 3, or 12. 9 plus 12 is 21. So the total distance walking along the sidewalk would be 21, while total distance cutting across the diagonal is 15. So you would save the difference, or in other words, 6 feet of walking distance. Okay, let's do one more applied problem here. Suppose you have an object, just any object that's, helps to think of a heavy object, okay, that's thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. So the height of the object after t seconds is given by this equation. This comes from physics. So how long after the object is thrown will it be 100 feet from the ground, meaning 100 feet above the ground still? Okay, so this gives us the height of the object t seconds after it's thrown. The question is, how long after the object is thrown? How long means we want which variable? T, because t is t seconds, that's time, so we want t. After the object is thrown, will it be 100 feet from the ground? If something is 100 feet from the ground, then in terms of these variables, that means its height above the ground is 100, which means h is 100, because h is height above the ground. So when is its height? 100. That's what we want to know. So we can plug in 100 for h and solve for t. To get 100 equals negative 16t squared plus 12t plus 200. Well, that is a quadratic equation. Okay, so we would need to set it equal to 0. So we can subtract 100 from both sides to do that. And solve from here. Now before I start trying to factor or use the quadratic formula, I like to see if things will simplify. So let's see, the largest number that 16, 12, and 100 are all divisible by, let's see, it must be 4. So let's take a 4 out of everything, and I would be left with negative 4t squared plus 3t plus 25. That just makes it a little easier. Now if I divide both sides by 4, basically goes away. The other thing you could do is you could have factored out a negative 4 and divided by negative 4 if you don't like having a negative for your leading coefficient right here, but that's optional. So we have 0 equals negative 4t squared plus 3t plus 25. Okay, maybe this factors, maybe it doesn't. It looks like it would be kind of hard to factor and it might end up taking a while. So I'm going to jump straight to the quadratic formula. This time it's not x equals, it's t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative b is negative 3 plus or minus the square root of b squared is 3 squared, which is 9, minus 4 times a, that's negative 4, times c is 25, all over 2a, so all over 2 times negative 4. So let's keep going and simplify. So we get under the radical 9 plus 4 times 25. Well, 25 times 4 is 100. 100 times 4 is 400. So 9 plus 400. I doubt 409 is a perfect square, but maybe we can simplify it. Let's see. To simplify it, you would have to find some number that it's divisible by. Can't find any number, or at least not any small prime numbers, that 409 is divisible by, and I don't know offhand if that's prime. So instead, why don't we just keep going with this and approximate, because ultimately this is an applied problem for which we want to round to the nearest tenth of a second anyways. So let's approximate here. We have two solutions. We have -3 plus radical 409 over -8. And we have -3 minus radical 409 over 8. So we're going to need to approximate each of those. And when I round those, I get -2.15297. And I get approximately 2.90297. Obviously, a negative time doesn't make sense, so that one we'll ignore. And then if we round to the nearest tenth, that would be about 2.9 seconds after the object is thrown, that it will be 100 feet above the ground. That's it for this section. Tune in next time for 11.3.